All right, so it's in descending order. It's simplified. The next thing we look for is what? Greatest common factor. What do all three of these have in common? They all have an x, at least one x. All right, so the greatest common factor is x. If I pull an x out of each one of them, what's that leave in parentheses? X squared plus 2x minus 15. So we get this quadratic left in the parentheses. And we want to try to factor it using the rest of the rules. So there's how many terms in this? 3. So that tells us to use which method? The x method. What goes in the top of the x? Y'all remember that? 2 goes in the bottom. Negative 15 goes in the top. So we're looking for two numbers that multiply to be negative 15 and add to be positive 2. 5 and negative 3. Good. Can I use the shortcut to go straight to the factors? Why? Yeah, there's nothing in front of the x squared, so that lets me go straight to x plus 5 and x minus 3. The x that I pulled out at the beginning, still there. That's the factored form of that original polynomial. That's what we're after today, is trying to factor those. Once we get this factored form, we get to the solving step. It's super easy from there. But the factored form, that's the hard work. We got to get there first. Example B. 2y to the 5th minus 18y to the 3rd. Descending order? Yeah, we got 5th power, 3rd power. GCF. 2y to the cube. Yeah, 2y to the 3rd. Yeah, exactly. There's 5 of them here and 3 of them here. So there's 3 y's that they have in common. 2 goes into both of them. So we're going to pull out a 2 with that. So that'll be 2y to the 3rd. If I pull 3 y's away from 5 y's, how many are left? 2 of them. So that's y squared. I also pulled the 2 out. So there's really a 1 in front of that. And then 18y cubed, what's it turn into when I pull 2y to the 3rd out? If I pull a 2 out of it, it'd be a 9, right? It's like dividing by 2. So that'd be a minus 9 left in the parentheses. And then the y cubed, I pulled all 3 of them out here. So there's no y's left on that 9. Then I look at what's left in the parentheses and say, can I do anything else to that? There are 2 terms. So my options are either differences of squares or differences of cubes. Well, that's a y squared, so that should point us to differences of squares, right? What squared gets me 9? 3, right? So that would be y plus 3, y minus 3, correct? And then the 2y to the 3rd still out front. And there's the factored form of that polynomial that we started with. All right. Not too bad so far. 4x to the 4th minus 16x cubed plus 16x squared. Cube looks stupid. So I'll fix it. Yeah. Still looks dumb, but that's okay. All right. What's first? 4x squared will come out. Good, good. GCF. What's it leave in the parentheses? Yeah, 4x plus 4. And then we look at that trinomial that's left, and it's a quadratic trinomial, so that tells us to do what method? X method. Multiply to be positive 4, add to be negative 4. What could do that? -2 and -2. Can I go straight to my factors? What's in front of x squared? Nothing. There's a 1 in front of that, so that allows me to go straight to x minus 2 and x minus 2. You can write it that way, or how else could we write it? Yeah, we could do this. Either of those is correct. I would take either one of those for sure. If we're going to solve, this way may be better, but we'll get there in just a little bit. All right, let's look at the sums and differences of cubes. Okay, let's look at the sum of cubes first. So this is something you'll need to memorize and know. Last year, I know they did not give this. I want to say formula, but it's not really a formula because you're not getting an answer here. It's a pattern. If you've got something cubed plus something else cubed, that's a sum of cubes because it's a plus sign. The way it factors is you've got a short piece and a long piece. Okay, the short piece is always the same sign, so it's a plus sign in the middle. And whatever is cubed in the front, like here it's A, goes in the front. Whatever is cubed in the back goes in the back. It's B in this case. We're going to do an example with numbers and letters, other letters in there. But the short piece, if you'll remember, the short piece is the same. That's going to help you on the sum and the difference of cubes. So if it's a sum of cubes, the short piece should be plus. The long piece is a quadratic, and it's what's left over. Okay, if I use one of the A's here, how many are left? There's 2 of them, so it's A squared right there. Same thing with the B. If I use one of them here, there's 2 of them left, right? So on the end, put plus B squared. In the middle, it's
Ryan Sparks, report to the office.
The opposite sign, and then the product of the 2 pieces that are cubed. Let's look at an example that's got some numbers in it so we can kind of figure out what's going on here. Let's start with something easy like x cubed plus 8. All right. The key to doing a sum or difference of cubes is rewriting it as a sum or difference of cubes, just like we did when we learned how to do difference of squares. If you can rewrite it in that form where you got something cubed and this is a plus, so plus something else cubed, then it makes the pattern really easy to follow. Okay, what cubed gets me x cubed? That's the easiest one, x, right? What cubed gets me 8? 2 times 2 times 2 is 8, so that's what goes there. That gets us the A and the B from our pattern. A is x and B is 2. So our factoring for that is you got a short piece, it'll be x plus 2. Then you got a long piece, it's going to be x squared in the front, 2 squared in the back. And I'm not simplifying on the first line here on purpose for notes. Now, when you get in the habit of doing these, you would obviously write that as 4, right? Because 2 squared is 4. And in the middle, it's going to be the product of the 2 things. So 2 times x is 2x. And it's always a minus sign there if it's a sum of cubes. That's the factored form. The beauty about sums and differences of cubes, this long piece will never factor any further. I boxed that in like it was the answer, and it's not. We got to finish that. We got to fix that 2 squared. Sorry. Two squared is 4, right? So you'd write it as 4. There's nothing that multiplies to be 4 that adds to be -2. This long piece will never factor any further. The short piece, it's not going to factor any further either because it's always going to be, something short like that, an x plus 2 or something. That would be the final answer. on the factored form of that. Let's do one more sum of cubes. See if we can figure that out. Let's do one with the number in the front, like 27 x to the third plus 64. All right, so the key is figuring out what cubed gets me 27 x to the third. Three times 3 times 3 is 27. So that'd be 3. And then we need an x to get the x cubed, right? So we've got a 3x in the front. Because 3x times 3x times 3x is 27x to the third. That's why we're using that piece. Okay? And then what times itself 3 times gets me 64? 16 times 16 is 2. Oh, you mean 4. Okay. That's okay. 4 times 4 is 16 times 4 is 64. So 4 cubed is what 64 is. Yes, sir. Because you need to know what cubed got me this. What cubed got me the 27x to the third. Okay, that on the previous one we had the x cubed. We didn't have a number in the front. If there's a number in front and no GCF to pull it out with, then you gotta figure out what gets me that number. So that's why we had to do the 3x there, because we need to break that number down to what cube gets me that number. All right, so we've got the A and the B from our pattern. So the short piece, 3x plus 4, that's the easy part. Now, the long piece, a little bit more difficult this time because you got numbers involved with both pieces. So we've got 3x squared. So I'm gonna, if I write it out, long form, 3x squared, and then on this end we got 4 squared. In the middle, we're getting 3x times 4. That's what's going on there. That's the completely unsimplified version of that. And then we simplify it. So 3x plus 4 in the front. What's 3x squared? What's 3x times 3x? 9x squared. And then in the middle, 3x times 4 would be 12x. And then on the last part, 4 squared is 16. And there's the factored form of that sum of cubes. And if we tried to factor this trinomial that's left here, it won't factor any further. 9 times 16, 90 plus 54, 144, and add to be negative 12. There's nothing that does that. So it won't factor any further. Okay, so there's sum of cubes. Let's look at the difference of cubes and get that pattern. The difference of cubes, you got something cubed minus something else cubed. The short piece is the same, so it's A minus B. The long piece, all of the terms are the same. It's A squared, AB, and B squared. The only thing that changes, that sign in the middle to a plus sign. So if you can memorize one of them, the other one you just change 2 signs. Flop the middle sign, the signs that are in the middle. It will always be a plus sign down here because you're always going to get a positive answer when you square something, right? If I square negative 4, I get positive 16. So that's why it's always a plus right there. Always a plus. The middle one is the one that changes. Okay. All right. So let's look at some examples of differences of cubes. F. Example F. Let's do x cubed minus 27. All right. So again, the idea is to rewrite it as something cubed minus something cubed, or try to do that. The thing that gets you to think about that method for this is that there's only two terms, and one of them has an x cubed on it. That's what makes you think that. Okay. What cubed gets me x cubed? X. What cubed gets me 27? 3. We already know those numbers. We've used them in other examples. Now, the pattern, what's the short piece? X minus 3. The long piece will be x squared. The other end is going to be 3 squared. And then in the middle, we got 3 times x. What sign goes in front of that? Plus. Yeah, always a plus. Simplify that just a little bit. And there you have the factored form of a difference of cubes. Let's do 8x cubed minus 125. So again, you got two terms, and one of them has a cubed on it. Hey, Miss Becky, did you have a good fall break? Good. It was a good fall break then. All right. So two terms, got a cubed on one of them. That's what triggers you to think sum or difference of cubes. Okay. So what cube gets me 8x cubed? 2x. What cube gets me 125? 5. When they're doing sums and difference of cubes, guys, they're not going to get really huge numbers. Like, I mean, 5 cubed is already up to 125. 10 cubed, 10's a pretty small number. 10 times 10 times 10 is 1,000. The numbers get really large quickly when you cube things. So your pieces for your factoring shouldn't be very big numbers. You're not going to have, 5-digit numbers or 6-digit numbers that they're asking you to factor with. That doesn't. Polynomials get that large, nothing weird happens, but it doesn't seem to make sense for us to work on that here in high school algebra. Okay. So what's the short piece then? 2x minus 5. The long piece, let's see if we can do it without the middle step. What's the first term? 4x squared. Where's that coming from? 2x times 2x. Yeah, 2x squared is where that's coming from. So the 4 is 2 times 2. The x squared is x times x. And then the middle piece, 10x plus or minus? Plus. Remember that the middle sign on the long piece is the opposite. The middle sign is the opposite from the original problem. Okay, and then the last piece, plus 25. There's the factored form of that difference of cubes. You can learn those patterns. Some of the easiest factoring that you have to do in this whole thing here. Okay. All right, let's mix it in with what we've been doing already. So back to the simple instruction factor. Let's say we had 2x to the 4th minus 54x. Is it in descending order? Yes. And then next thing we look for, greatest common factor, because we see a 2 in the front here and a 54. We know those numbers are both even, right? So we know they can divide by 2. What else do they have in common? An x. So if I pull a 2x out, what's that going to leave in parentheses? X cubed minus 27. And then that's a difference of cubes left in. There's 2 terms. So we pulled out the GCF. We're to the step where we're counting terms. There's only 2 terms. It's an x cubed, so that should say, okay, it's if it will factor, it's a difference of cubes. So you've already done this one or done these numbers. We know that that's what that's doing, okay? 54 divided by 2. You got it? All right, JP.
It says 2x to the fourth minus, if it's plus, is it negative?
Absolutely. Perfect. Yes. If here it was a minus, if JP said if it said plus would be a sum of cubes, yes, absolutely. It would be a sum of cubes. All right, so the factored form here, we got the 2x we pulled out in the front to begin with, and then we got a short piece and a long piece because we know it's a difference of cubes. What's the short piece for this difference of cubes? X minus 3. Good. What's the long piece? X plus 3x plus 9. Didn't need to be that long. There's the factored form of that fourth degree polynomial. I'm saying fourth degree because the highest exponent's 4. That's what that means. Okay. Not bad. Not bad at all. Let's throw this one in there. See what happens with it. X cubed minus 3x squared minus 16x plus 48. Yikes. Any GCF on that one? No. So how many terms we got? 4. It's in descending order already. We kind of just skipped over that. But what method do we use when it's got 4 terms? Grouping. So I'm going to group first 2 together and do GCF on that. What's the GCF of x cubed and negative 3x squared? X squared. What does that leave in the parentheses if I pull an x squared off of both of those? X minus 3. Okay, then I look at the second pair. I got a negative 16x and a positive 48. 16 is the GCF. Because this term has a minus sign on it, let's pull out a negative 16. Because that will leave, if I pull out a positive 16, it doesn't have the right thing in parentheses. If I pull out a negative 16, that changes this x to positive x. And 48 divided by negative 16 would be negative 3. So then those parentheses match. When you're doing grouping, those parentheses there have to match for it to work. Okay? If they don't match, something's not right. Either it won't factor or you maybe pulled out the wrong GCF of a group. Okay? So once you've done that, you've got the matching factors of x minus 3. And then the stuff that's in front, x squared minus 16. Will either of those factor further? It's adding space, so it must. Yeah, the x squared minus 16, it's got 2 terms. It's a squared with a minus sign in the middle, so it's a what? What's it called? Difference of squares. What squared gets me x squared? X. What squared gets me 16? 4. One's a plus, one's a minus. And now we've factored that completely. We have to factor things all the way if we can. That's what we want to try to do as we're going through this stuff. All right. So 4 terms, grouping method. We've done grouping before. Not as extensively as we wish, but did I skip a letter? I don't know. Maybe I had an extra example. All right. Let's do solve polynomial equation. All right. Remember back when we were doing quadratics back in quarter 1, if you were going to use factoring to solve a quadratic, what did it have to be equal to? 0. It had to be equal to 0. So when we're dealing with polynomial equations, it's the exact same rule. It's got to be equal to 0 to solve it by factoring. Okay, so we're going to start with 4x to the 5th minus 40x to the 3rd plus 36x equals 0. So we have a polynomial with 5th degree is what we would call this, because it's got the highest exponent of 5. So when we're doing this, we know when we're solving a polynomial, we should be able to find 5 answers to this, because the highest exponent is 5. Whatever the highest exponent is, that's how many answers you should get. And that's an important thing to know. Okay? And we're going to use factoring to solve this. So the first thing that I look at is it in descending order? Yes. Is there a GCF across the whole problem? What? 4x. So I'm going to pull a 4x out to the front. What does that leave in those parentheses? X to the 4th. All right. Now, how many terms are in here? 3. So that tells us what method? X method. All right. It looks a little different because it's not a quadratic. It's got an x to the 4th in it, but it's got 3 terms. That still works with the x method. Okay. So when I do the x method, 9 goes up top, negative 10 on the bottom. What numbers multiply to be positive 9, add to be negative 10? Negative 9, negative 1. Okay. Now, is there anything in front of x to the 4th? No. So I can go straight to my factors. Here's the difference. The factors are not x minus 9 and x minus 1, but x squared minus 9 and x squared minus 1, because it's 4th degree. The 4x is still there. Now, if this were x to the 6th and then an x cubed there, your factors would be x cubes. Look at the middle term. It's an x squared. When we were doing the quadratics earlier today, the middle term was a plain x and our factors were plain x's, right? So here with an x squared in the middle, your factors are going to be x squareds. If it was an x cubed in the middle, your factors would be x cubes. If it was an x to the 4th in the middle, your factors would be x to the 4ths. It's always whatever that middle term is. If you use the x method to factor, whatever the middle term is what your factors are going to be. Now, will x squared minus 9 factor further? How? It will. How? Difference of squares. So that'd be x plus 3, x minus 3. What about x squared minus 1? Is it a difference of squares? Is 1 a square number? Yeah, 1 times 1 is still 1. So that's a square number. So that's x plus 1, x minus 1. We've got 1, 2, 3, 4, 5 factors. All of them have an x in them. When we were doing quadratics, once you got it factored, what did you do with each factor in order to solve it? Set it equal to 0. So we're going to set each one of these equal to 0. 4x equals 0. X plus 3 equals 0. X minus 3 equals 0. X plus 1 equals 0. X minus 1 equals 0. And then solve them. This should be the easy part. Divide by 4. X equals 0. That's one answer. Minus 3. X equals negative 3. That's the second answer. Plus 3. That's positive 3. There's the third answer. X equals negative 1. X equals positive 1. How many answers we got? 1, 2, 3, 4, 5 of them. What was the highest exponent in the problem? 5. That should go together. Okay. Even if some of them repeat, if they repeat, they count another time. Like if you had x squared, plus 7, then you know that I, or plus or minus I radical 7 is a solution. We'll get that in a second. But idea here is solve it, use factoring as much as you can, and then we may have to use something else if we need to. Let's look at one more here. Negative 27x to the third plus 15x squared equals negative 6x to the fourth. What's wrong with this one? Doesn't equal to 0. What's the quickest way to get it to equal 0? Yeah, moving the 6x to the fourth. If you wanted to, you could move these two things over there and get it. That's fine. Doesn't matter which way you go. But I think adding the 6x to the fourth, that's the quickest way. Why did I put it out to the front? So it'd be in descending order. Exactly right. 6x to the fourth minus 27x cubed, 15x squared. Now it's equal to 0. X squared. Sorry. What is there a GCF to this? 3x squared. 3 goes into 6, 3 goes into 27, 3 goes into 15. And they all have 2 x's in common. So 3x squared. That leaves what in the parentheses? Good job. How many terms are in that? 3. So that triggers, if I'm going to factoring, that triggers me to try the x method. 2 times 5 is 10, and add to be negative 9. Multiply to be positive 10 and add to be negative 9. Negative 10 times negative 1 adds to be negative 11. That doesn't work. Negative 5 and negative 2 adds to be negative 7. That doesn't work. And that's all that multiplies to be 10 and could add to be a negative. So that doesn't factor any further. What do we do now? We set each factor equal to 0 to solve it because we're trying to solve this thing. So if I set 3x squared equal to 0 and then 2x squared minus 9x plus 5 equal to 0, I can solve this one pretty quickly and easily. So I'm going to go ahead and do that. So I divide by 3. 0 divided by 3 is 0. And then how do I get x to be not squared now? Take the square root. Technically, there should be a plus or minus in front of this. But is 0 positive or negative? No, it's neither of those. So when you do that, it's x equals 0. That counts twice because it came from x squared. And we know it counts twice. That's why we're saying x equals 0 twice. How many answers should we have for this problem once we're done? 4, because the original problem had a 4th power in it. So we know that's the biggest exponent. That's how many answers we should get. This is 2 of them. How many are we going to get from this one? 2, because it's x squared. If it won't factor, what are my other options for solving it? Because it's a quadratic. What's my other option? Dun, 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 dun. That song, yeah, that's the one. Quadratic formula, guys. That's our other option. If it won't factor, quadratic formula is the way you want to go, unless it's something like x squared plus 72, and you can do square roots quicker. So x equals negative b plus or minus the square root b squared minus 4ac, all of that divided by 2a. That's the quadratic formula. Got to know that. So when I go to do that work, negative b. B is negative 9. So the opposite of that is positive 9, plus or minus. And then I got negative 9 squared minus 4 times 2 times 5. All divided by 2 times 2. That's the everything plugged in the right spot for quadratic formula there. Work that out. It'd be 9 plus or minus. 9 squared is 81 minus 4 times 2 is 8 times 5 is 40. So that would be the square root of 41. And then 2 times 2 on the bottom is 4. Does the square root of 41 simplify any? 41 is a prime number, so we can't break it down any. Okay, so we get two answers: 9 plus the square root of 41 over 4, 9, and then 9 minus the square root of 41 over 4. Remember we did decimal approximations for that back when we did those? So 9 plus the square root of 41, then divide that by 4, is 3.85 about. 9 minus the square root of 41 divided by 4 is 0.65. Those are our two solutions. The exact solution is what I really want, but these are going to be important when we start looking at the graphs later on this week, knowing where those are across the x-axis. So 1, 2, 3, 4 answers at fourth degree polynomial. Fourth power was the highest one. We're going to get that same number of answers. Had that been a negative 41 underneath there, what would it have done? Pulled an I out to the front. So we'd have complex solutions as answers. We can still find them. We've dealt with complex numbers already, so you don't have to separate it between real numbers and complex. We still have already done that before. So it just takes that practice. Factoring is the main thing. If you can't do the factoring, you're probably never going to get to the quadratic formula step. Okay, so the factoring is the main stuff we're working for here. So this is what I want you to work on. You got about 30 minutes left today, and then you got some time tomorrow if you're not here. And then we'll take some time on Wednesday and probably work some of this and a little bit more to practice. Tomorrow is ACT for seniors in the morning, and then parent-teacher conference tomorrow evening. Just the parent-teacher conference was next week, next Tuesday, and they had swapped it because the state came back. The calendar for this year was approved last spring, like in spring of 2017. So the state this summer decided, hey, seniors are going to get a chance to take it in the school building during the school day, and we had to choose a day. So instead of losing 2 days by having you guys be gone, and then having parent-teacher conference a separate day, our folks decided let's do it together, which I guess makes sense. So you don't have to be here tomorrow, but I do. Do what now? Yeah, that was confusing. I'm not sure. From everything I've heard here, it's just seniors. Junior, yours is in the spring. You'll get a day where you come and take that, and everybody else stays home. And then fake news.